Ready to use some Rego with your Terraform execution plans? This is the video for you. What's up, everybody? It's Ned Bellavance, Ned1313 on Twitter, and welcome to Terraform Tuesday, and also Happy Pi Day. It is for those of us who are in the US and use our ridiculous dating nomenclature. It's March 14th, or 3.14, which is, the first three digits of pi, so we call it Pi Day. Also happens to be my wedding anniversary, which, yes, was intentional. I married a math teacher, so little fun aside there for you. In this video, we are going to dig into how you can use OPA and Rego to evaluate a Terraform execution plan. This is the third part of the series so far. In the very first one, I laid the groundwork, just the foundational concepts of how OPA and Rego fit into evaluating Terraform and using policy as code. In the one after that, we took a look at some basics around OPA and the Rego language and how to use the OPA interactive shell to test out different statements in Rego. We're going to take all of that knowledge and now apply it to Terraform by producing an execution plan and then evaluating that execution plan using OPA and Rego. So that's the ground that we're going to cover in this video. And then in the next video, we're going to build out that knowledge to create a series of tests for different resource types and also just some general testing that you might want to do to evaluate changes that are going to be made to your environment. And then in a future one, we're going to move on to how you can then add that testing to your CI/CD environment, whether it's through Terraform Cloud or M0 or GitHub Actions. Lots of options there. So that's the overall plan. Let's dive into the topic today, which is evaluating a Terraform execution plan using OPA. Okay, I have loaded up a repository in Visual Studio Code. The repository is called Learning OPA and Terraform. If you're looking for these files because you want to follow along, you can find the link to my GitHub down in the description. A few other prerequisites you'll need if you want to follow along. I'm using Azure for my example code, so you're going to need a valid Azure subscription as well as the Azure CLI installed, because that's how we're providing authentication to the Azure RM provider. You don't have to use the CLI, but hey, it's the easiest way to do it on a workstation. The other two things that you'll need is the Terraform CLI as well as the OPA CLI. I believe I'm using 0.5 of the OPA CLI, but just grab whatever the current version is if you don't already have it installed. Okay, with those prerequisites in mind, the next thing to do is generate an execution plan. If we take a look at what's in the main.tf file, this is a pretty simple configuration. I'm creating an Azure resource group, and then in that resource group, I'm going to create an Azure virtual network, and then within that virtual network, I'm going to create two subnets, and I'm using a for each loop to generate those subnets. Note that I'm not using any child modules in this example. I'm keeping it relatively straightforward so that we get a relatively simple plan file to work with. So let's generate that execution plan file. Now, the way you generate a plan, of course, is by running Terraform plan. So we'll do that. We want to save that execution plan to a file, so we'll add the -out argument and set it equal to the file path we want to send it to. In this case, I'm going to send it to a file called plan.tfplan. And you don't have to call it .tfplan. Any file extension or no file extension, honestly, works. For me, I have tfplan in my list of files to ignore in gitignore, so I don't accidentally commit a plan to source control. So that's why I use .tfplan. All right, so we'll go ahead and run this, and this will generate our execution plan. Now, the thing about the execution plan that gets generated is that it's not in human readable form. It's in binary form, which you can't read and neither can OPA. So we're going to have to do a little transformation of this execution plan into a format that OPA likes, namely JSON. So this is going to take a moment for it to generate, but once it's done, we should have an execution file. And the next thing we're going to do is create our JSON file based off of that. The command we're going to use to do that is terraform show, And then we're going to use the -JSON argument to signify I want the output to be in JSON format. And then what do you want to show? We'll pass it the tf-plan file, and then we're going to direct the output to a new file called plan.json. So the plan has finished generating. If I click on it, it's going to tell me this isn't binary. You can't view it. So we're going to go ahead and run this command right here. There we go. It has converted that binary to JSON. Now, if we try to take a look at it, because this is meant to be machine readable, it just puts it all in one line. Let's prettify it a little bit using prettify JSON, which is one of the extensions in it. And then scroll all the way down. This simple execution plan that's creating 4 resources is almost 500 lines long. So there is a lot of information in this execution plan. Probably doesn't make sense to try to walk through it looking at it this way. Instead, let's spin up the interactive shell for OPA and feed the file in. So the way we're going to do that is run OPA run, and then we're going to pass it this file, plan.json. It's going to load that into the virtual data document. So if I look at what's in data, it has the entire execution plan in there. Now, let's take a look at what the top level keys are for our execution plan. Let me give myself a little more room here, and we'll do data, and then we want to iterate over the entries in data. So we'll say key is our iterator, and when we do that, it'll use key as one column, identifying the keys at the top level, and then the data that's stored in each of those. So we have, what, 7 top level keys available to us. Now, some of them are going to be more important than others. So let me briefly go over what each one is. The configuration key holds the rendered configuration from your .tf files. So it basically takes everything it finds in your .tf files, that's your Terraform configuration, and converts that all to JSON. So that's pretty useful. If you want to parse your configuration in JSON, there you go, you can do it. Now the next interesting one is planned values. Planned values is going to be the values including the resources and the variable values that were submitted for the configuration that's actually going to be applied. So the difference between the configuration and the planned values is the planned values actually has all of the variable values loaded into it. The next interesting one is resource changes, and this is exactly what it sounds like. It's a list of resources and what's going to happen to those resources, whether they're going to be created, updated, or destroyed. And replaced is another option, which is really create, destroy and then create, or create and then destroy, depending on the order you have in your life cycle. The last one is variables. Variables is a list of the variables that are defined in your configuration and the values that you've submitted. So if you want to parse your variables, you can do it that way. So the next thing that we can probably look at here, probably the most useful one, I'd say, is to take a look at the planned values. Now the planned values path we're going to look at is this one, which is data.plannedvalues.root_module.resources, and we'll use keys to iterate over the values there. And this gives us our 4 resources that we're going to create, as well as all the values that are used for the creation. So if we want to take a closer look at a specific one, we can change keys to just the first element of this list. And now we can see we've got our resource group here, and it has the information in it, like the location that's being used, the name that is being used, and the tags that are going to be applied. And all of that information came either from another resource, well, in this case, it all came from variables to render this out. If we want to look at a different one, just change the number. Now we're looking at a subnet, and some of the values for the subnet actually come from other resources that are in the configuration. So that's something that we could look at in our planned values. Now note, I'm not using any child modules, so all of this is just in the root module for now. Next, let's take a look at how we could get more information about a specific resource type that's in our planned values. So I have an expression here that will pull out all the subnets that are in our planned values in case we wanted to look up something about subnets specifically. So the expression goes, I'm defining a variable called subnets, which is going to contain a list of subnets that is using the subnet variable placeholder. And then I'm defining the subnet variable placeholder as a set of the values that's in the planned values root module resources. So all those resources we already looked at, but I'm putting a further constraint on there that subnet.type equals Azure RM subnet. So if I add this rule, copy it and paste it down here. Now that I've defined this rule, if I put in subnets, it will show me the two subnets that are planned here. So subnet 1 and subnet 2. That's pretty cool. Okay, what else can we do here? Well, let's move over to the resource changes, because this is probably the most commonly inspected portion of the execution plan. You're planning some changes. You probably want to know what the impact of those changes is. So we can examine what's in our resource changes by doing data.resourcechanges.keys. And there are 4 keys in here. That's not surprising. We're creating 4 resources because right now there's nothing in the target environment. So if you look at what's in the values, we have the address of the resource and the change type that's happening. And if we want to take a closer look at one of these, let's take a look at the first entry in the list. So I'll change it a little bit. And in here, taking a larger look at it, we have our resource group, and it logs the change type under change actions. So we know that we are creating this object. It also has the after properties. What are the attributes of this resource after the change has happened? Below that, it has the values of before, and that's set to null because this resource doesn't exist yet. If we were altering this resource, updating it, then it would show us what the values were before and then what they're being changed to. So that's interesting. If you want to inspect updated resources for some reason, then you could do a comparison of before and after attributes. It also lists out the name of this resource as well as the type. So we have some more things that we can filter on when it comes to looking at our resource changes. Okay, so just in the same way that we created a subnet filter for our planned values, we can create a subnets that are being created filter for our resource changes. So the syntax is going to be pretty much the same. We're creating a variable called subnets created. We're creating a rule called subnets created, and we have a variable in there called subnet that is going to make up the contents of this list. And inside of the definition for subnet, we're assigning subnet the values in resource changes, where the type is equal to Azure RM subnet, and the change.actions is equal to create. So this should only give us subnets that are being created. So let's go ahead and copy that, paste it down below. And now I can inspect subnets created. There we go. Here is my subnets created. Excellent. So it did exactly what we would expect. We now have a way to easily get the type, filter on the type and the action. But I might want to make this more general, right? Because this is something I'm probably going to want to do pretty often. So it would be pretty cool if I had a function where I could pass it a resource type and perhaps an action, and then get back a list of that resource type and action. So let's create a function in Rego. So we are going to create a function first to get resources by type. And this will take 2 arguments. It'll take the resources as well as the type that you want to filter for, and then it will return back that information. So let's go ahead and load up this function. If you look at the function, we're essentially passing the 2 arguments, resources and type, and then filtered resources is the value that we're populating, and filtered resources is defined as a list of resources where we've loaded up resource with all the resources that are being changed, and the resource type is equal to type. So let's grab this function and just drop it down here. Now we have this additional rule called get resources by type. Now we can use that partial rule by feeding it in a list of resources that we want to filter on. So I already have a subnets, right? We already created that. So first we have to unset our existing rule for subnets. All right, we've unset that one. Now we're going to create a new rule to define subnets. We're going to use our function getResourcesByType. We're going to pass it the list of resource changes as well as the type Azure RM subnet. So I'll grab that. There we go. That rule now exists. And now if I do subnets, I get the list of 2 subnets that are being created. And I know it's just subnets. It's none of the other resources that are in there. Now that seems like pretty useful. The sort of function you're going to want to use a lot. In fact, you could probably think of a bunch of other functions you might want to use often across all the different Terraform configurations you might want to inspect. So what I did, and you can expand on this as you want, is I created a file called terraform_library.rego that defines some of these helper functions. And so it is part of the package terraform.library. And inside of the package, I have a function to get resources by type, get resources by action, get resources by type and action in case you want to filter on both. I only want, resource groups that are being updated, maybe. And then also get resource by name. So I want to get a specific named resource and get resource by type and name. So all of these functions are available within this library of functions. Let's see how we make use of those from the interactive shell. And first we actually have to exit out of the interactive shell and go back in with a slightly different command. So it's still OPA run, but now rather than passing the plan.json directly as data, I'm going to specify that it's part of the input package. So now this is considered input and I can refer to it as part of the input. And then additionally, I'm going to add terraform library.rego. That will get added to the data and I can import the contents of that file as part of my library. So I'm going to go ahead and run this command here. There we go. And the first thing I want to do is import that library of helper functions from the data document. So I'll run import data.terraform.library. Now I have those functions available from the library name. And I also want to import the plan file as tfplan from my input values. There we go. And now I can use a function that's found in the library. Let's say I want to get resources by type. So it would be library.getResourcesByType and then pass it the type. Let's go ahead and run that. And there we go. Our function works exactly as we would expect it to. Now, we can use those functions in our library to filter on resource types and names and actions, etc. And we can also build rules based off of what's returned by those. So let's say I wanted to look for a situation where there are too many deletes in my configuration. So I'm going to use get resources by action, get me all the deletions that are happening in my resource changes. And if it's greater than 5, then set too many deletes to true. And then that gives me a clue that I might want to take some sort of action. I can check to see what the status of that value is when I'm actually running my policy checks for OPA. So we're building up sort of a library of checks based off of some helper functions. So I'll go ahead and run that command for too many deletes. Now, there are no deletes in our resources changes at the moment. So if I look at what's in too many deletes, because it's not true, it gets set as undefined. We could set too many deletes to, now we'll say less than 5 instead. And now we'll test to true because there's definitely less than 5 deletes in there. So this gives you a pretty good idea of how you could start building up policies using these helper functions and the contents of the Terraform execution plan. All right, so now you know what is in a Terraform execution plan, how to convert that to JSON and bring it into OPA to mess around with it using Rego, how to create helper functions in Rego to perform common actions and routines that you might need when you're parsing that execution plan, and then how to create a rule using one of those functions to evaluate, say, there's too many deletes in my plan and maybe I don't like that. In the next video in this series, we're going to see how to tie all those pieces together to run OPA non-interactively. So instead of running it in this interactive shell, we're going to pass it some policies and the execution plan and then inspect the results and see what that looks like. We'll also get into some more formal policies where we can check for specific virtual machine sizes or whether there's too many creates or too many deletes in our execution plan and what constitutes too many to begin with. So we'll have those more formal parameters and we'll see how we can run it non-interactively. And then finally, we'll get into adding this into a CI/CD pipeline so you can check this using policies as code. That's going to do it for today. One quick reminder before you sign off, I just want to let you know that for the month of March, my Terraform certified guide is $5 off. It's only $10 over on LeanPub, and that's to promote the fact that the newest version of the Terraform exam has been released, Terraform version 003. So if you're thinking about sitting the Terraform associated exam, you can get my study guide down in the links below. Thanks everybody for watching. Till next time, stay healthy, stay safe out there. Bye for now. Hey, it's me a few days later. I didn't actually get to publish this on Pi Day because I was teaching a Terraform advanced class for 3 days. So it's a couple days late, but hey, the content is still relevant and I hope you enjoyed it. See you next time. Bye.